quantitative data here. It says quantitative data are data that can be counted or expressed numerically. So that's anything that can be counted or measured with numbers. What are some examples of quantitative data that you can think of? For me, what comes to mind would be like height, shoe size, age, great. Yeah. Any others? One more, give me one more.
Weight.
Yeah, exactly. So, have you guys heard of qualitative data? Qualitative? Could someone maybe explain briefly what that is? Maybe. All right, qualitative basically is data that involves variables that can't be counted or measured with numbers. So think of it as a description of the qualities of the data that you're looking at. So we have quantitative being a quantity that you're looking at. And qualitative being a quality that you're looking at, I'm sorry. So it says that suppose you're exploring whether the steepness of the slope affects the speed of a cyclist. Cyclists from Team Blue were timed as they rode a hilly course. Their speeds, y miles per hour, climbing various inclines x, are shown in the table. So we have our two tables there. Have you guys heard of independent and dependent variables? And maybe in science class? Can someone explain to me what those are briefly? Maybe independent variable first.
Independent is the ones you can change and it doesn't affect anything, and the dependent is the ones that you cannot change.
Right, so the independent is the variable that we're changing or manipulating, and the dependent variable is the variable that is affected by that change. So in our example here, what would we say that the independent variable is? So what is the one that we're changing? Yes?
The angle of the incline.
Right, to see how that affects what?
The speed of the cyclist.
The speed of the cyclist, the dependent variable. So a scatter plot is a graph made by plotting ordered pairs in a coordinate plane. The points show the association between two sets of quantitative data, or in the bivariate data. There's two vocab words that are highlighted. Association being the relationship between the two variables that we're looking at. And bivariate data, which is data that involves two variables. So bi being the prefix meaning two, which you guys know. In this example being the cyclist, what are our two variables? We just talked about one being independent and one being dependent. So just in general, what are the two that we're looking at?
The angle and the speed.
Yep, exactly. So a scatter plot is created in a coordinate plane. Let one of the variables be represented on the horizontal axis, so the x-axis, and the other on the y-axis, the vertical axis. And then you plot the corresponding points usually from a table, like in this example. And this is a scatter plot of the cyclist. So again, on the x-axis, we have the angle of incline, and on the y-axis, the speed. It's zoomed in on the point 0, 6.2. Can someone explain to me what that point represents, where we got it? You need to look back in the table, that's a hint.
The 0 is the angle of the inch line and the speed is 6.2, like how fast the cyclist is going.
Yeah, exactly. So at an angle of 0, he's going 6.2. What's the next one say in the table? At an angle of 12, he goes how fast? Say it out loud. Yeah. Right, so if we look at that, what can we say? What do we say about the relationship there? If at an angle of 6 degrees, the cyclist is going, what, 6.2 miles per hour, and at an angle of 12, he's going, what, 2 something? 2? What do we say there? What if the angle of incline is less, the speed is faster? Yeah? And if the angle of incline is greater, then the cyclist's speed is slower. Yeah, exactly. The table shows the results of an experiment to determine the length, y centimeters, that a spring stretches when a mass of x grams is suspended from it. So we have our two tables, mass, length of spring, gives us our increments and labels for the graph. This is the scatter plot. Again, we have our mass, our independent variable on the x-axis, and on the y-axis, our length of spring. So if we look at this, what is the relationship here? At 600, the length is roughly 28, we'll say. And if the mass is 100, it's less than 15. So the heavier the object, the what of the string? How?
The length of the spring is greater.
Right, so the heavier the object, the longer the spring. Does everyone understand that? Bad if you do, fist if you don't. Great, okay. So this is where you want to get out your graph paper. I'm going to do a little practice one on your own here. We're looking at monetary exchanges between US dollars, X dollars, and Japanese yen, Y for yen, over a time period of 4 months at a major airport. So here again are two tables of data and the graph increments and labels. Where are you going to start? What's the first thing you're going to plot? First point. Look at the table. What will be the first point that you plot on your graph paper? If we know that the US dollar is the X and the Japanese yen is the Y, what would be, go ahead.
The US dollars and X.
Right, but what would be that point that you're first going to plot?
Up 10,
Yep, 10 and
8 over.
0.8, yeah. So your first point would be 10 and 0.8. So take like a couple minutes, try that one out. We'll go over it again together. Okay, so we said that our first point was what? 10 and 0.8, right? So that one would be roughly right here, right? What, can someone tell me what the second point is?
21.7.
21.7, and what's the corresponding Y value? What's 20 and 1.7. So on the x-axis we find 20, and our y-axis we find 1.7, so close to 2. How many of you, did you guys get to plot at least like 3 or 4 points on there? Yeah? Do you see how that process, can somebody maybe walk me through their thought process in plotting these points? Where did you start? Why did you plot it there? So we said that we looked at 10 and 0.8. So 10 US dollars compared to 0.8 Japanese yen. So if we have $20 or 20 US dollars, we have what? How many yens? What does that say? What does the table tell us? Yeah, 1.7. Okay, so we've been talking about associations being the relationship between two variables. We can identify those patterns in a variety of ways. So there are different types. There can be a weak association, a strong association, or no association. Those associations could be positive or negative, or linear or non-linear. So that depends on the clustering of the data points. What do you think they mean by clustering? What does clustering mean, just like in general? Yeah.
It's a cluster of points that are in.
Right, so data that occurs closely together, okay? So with the strong association, the data points cluster in a predictable pattern. You can see where it's going generally. With a weak association, the data points cluster loosely in a pattern that is less predictable. And with no association, the data points show no apparent trend at all. There's all over the place. Can anyone tell me what we would call a point like this, one that falls outside? An outlier, yeah. A number that falls outside of the majority of the values, usually a much larger or much smaller. So with a strong association, if the variables have a strong enough association, you can probably determine whether the pattern is positive or negative and linear or nonlinear. So again, the association can be positive or negative. When the two variables have a positive association, an increase in one variable corresponds to an increase in the other variable. When they have a negative association, an increase in one corresponds to a decrease in the other. 5 fifths. 5 if you get that, fifths if you don't. Okay, cool. Okay, again, it can also be linear or nonlinear. When two variables have a linear association, the points tend to cluster along a line. There's that word cluster again, meaning data that occurs closely together. Can also have a nonlinear association, so the points tend to cluster along a nonlinear pattern, so they don't quite make a line, a straight line. Data can also have a weak association. What is weak association again? Someone tell me. You can look back in your notes if you need to. Yeah.
It's when it's in a sort of a pattern, but it's not as predictable as a strong association.
Yeah, exactly. Exactly. So if the two variables have a weak association, it's harder to tell whether there's any pattern between them. Lastly, we could have no association. If the two variables have no association, you can conclude that the bivariate data do not have a pattern within them. So there's no rhyme or reason to where the points are. There's no relationship. Okay, so based on that, let's describe the association in these scatter plots. Again, remember we can have strong, weak, or no association. They can be positive or negative, linear or nonlinear. So we have 2 blanks here for graph E. Do the points seem to have a strong, weak, or no association? Do they occur closely together? Does it seem predictable? Someone say it, I'm nodding my head. Yeah, so strong. And would you say that's a line? No. So we would say this one would be strong and nonlinear. What about F? It's got 3 qualities. The first 2 were strong and nonlinear. Now we're looking at graph F. Does it look like it's positive? Yes, right? Does it look like it's strong? They occur close together. So we've got positive, strong. What's the last one I'm looking for here?
Linear.
Linear. Great. Exactly. And last one, graph G. What's going on there? Yeah.
No association.
No association, no rhyme or reason. There's just points everywhere. Okay, and that's it. Your guys' homework is page 183 and 184, numbers 1 to 7. And before you get started on that, although you guys probably don't want to, I have this little worksheet. It's like 1 to 3, just covering the topics that we talked about today.